In this podcast, I'd like to address the issue of the scientific method and the next generation science standards and just share my thinking about how I think those go together. So, most of you are probably familiar with the scientific method. In fact, most of the textbooks people use still has this in their first chapter. So, it's that notion of having students ask a question, they hypothesize, they move to an experiment, they draw some conclusions, and then report that. The idea behind that is that the scientific method is a step by step approach about how scientists do their work. And while that was generally accepted for a number of years, I think there are some issues with that approach. And let me share what I mean by that. In 1996, the National Science Education Standards were written. In the standards, the emphasis was really more on processes of science, with that idea of inquiry being the focus. So instead of a linear step by step method by which students do science, instead the emphasis was more on inquiry and processes. So we talked about process skills, things like observing, communicating, predicting, making inferences, defining operationally, classifying. We even moved into creating experiments, the whole experimentation piece. So those are what we began to define as processes. We felt that those were more along the lines of the way scientists do their work. In other words, these are the skills that scientists need to have in their toolbox in order to do what they do. So it's a shift away from a linear process and more beginning to see science as a fully integrated approach to answering questions and to finding solutions. So that began a paradigm shift in how teachers thought about how science was done and how students learned science. Well, the framework that came out in 2011 has this statement in it. It says that a focus on practices avoids the mistaken impression that there is a one distinct approach common to all science. In other words, there's a single scientific method, or that uncertainty in a universal attribute of science. So in reality, practicing scientists employ a broad spectrum of methods. And although science involves many areas of uncertainty, as knowledge is developed, there are now many aspects of scientific knowledge that are so well established as to be unquestioned foundations of the culture and its technologies. So the shift now is away from a single scientific method, and we recognize that scientists do their work as a result of many different practices. So when the next generation science standards took the materials from the framework, they really adopted that notion of practices. So those ideas of asking questions and defining problems, developing and using models, all the way down through obtaining, evaluating, and communicating. Those are the practices that scientists use to do their work. In addition to that, the framework also delineated for us what are called cross-cutting concepts. They are those concepts that cut across multiple science disciplines. So cause and effect, stability and change, structure and function are some of those cross-cutting concepts that you'll find in earth science, in physical science, in life science, and in technology and applied sciences. Then the framework defined for us four distinct areas of content: earth space science, life science, physical science, and then engineering technology science. So as we begin to think about teaching now, we want to help our students make sense of whatever it is they're learning. That's that sense-making piece. And then we also want students to be able to share with us what they've learned, and that's discourse. So when we think about a science lesson now, we shouldn't begin to, we should think of it more in terms of a practice approach to science, not a linear scientific method approach. And we need to keep all three of these dimensions in mind when we teach a lesson. So let's say we choose photosynthesis, for example. That's our science content. What are the cross-cutting concepts that apply to photosynthesis? Well, certainly there's stability and change. certainly their structure and function. I'm just kind of pulling some of these as I'm going through here. Um, it, the photosynthesis itself is a system, and so we can begin to take a look at what happens in a plant with photosynthesis as a system and create a system model. And then we can go to the practices and see what practices we need to be able to help students have at their disposal in order to make sense of the topic of photosynthesis. So a lesson is no longer just something isolated in a topic. It is layered with the practices, with cross-cutting concepts, as well as the content. So as you're thinking about this, these are the references to the images. Think less in terms of a scientific method, a step-by-step approach, and more of a holistic approach utilizing practices. I hope this has been helpful. Thank you.